I'm actually amazed at how good a time I've had here. I was initially a little bit nervous because I'm not really a Linux person, and I was trying to weave open source and Linux into the keynote somehow, but then decided I'll just talk about what I know best. And the audience was just great. And what's one of the highlights is just how nice the people are. There's a whole bunch of geeks together, and nobody calls each other stupid. When somebody loses something or needs help, immediately they get a bunch of people on the thing answering it. It was amazingly well organized. All of the special social events and everything were beautiful. They kind of weaved in sightseeing. All the talks were very well organized. So it's an incredibly good conference. So I'm at Intel. My title is fellow, whatever that means. And basically I do research on things. The kinds of things I like to do is, if at all possible, to make things just work automatically so that people don't have to understand the underlying technology. Also to make things evolutionary if possible, so not to tell people throw everything away that you have and invent this new thing. I also really like trying to get to the heart of when there's two competing things or many competing things, trying to figure out what's actually intrinsic to the differences between them. And I prefer not to look at two 600-page specs and compare them, but instead to break it into conceptual pieces where they might differ, and then talk about the pros and cons of those things. So starting with what I've done, I tend to do the very low-level plumbing that people hopefully don't even have to be aware of. And as a matter of fact, I was doing DECnet, the parts of it that moved the packets around and stuff. And I suppose one of the greatest compliments that I ever got was after we deployed it, and then the marketing department of Digital asked some of the major customers, "What do you think of DECnet?" And most of them answered, "What's DECnet?" even though they were using it. And so that's how I really want technology to be. But the things that I've mainly done is how to make a network. You just plug it together and the little components gossip amongst themselves automatically, figure out how to move data around, figure out if there are configurations, how to make the configurations compatible. So I've done that at layer 3. I mean, if one knows what the network stack is, layer 3 is the thing that traditionally moves packets around. The actual routing protocol that I designed at DECnet in the 1980s is actually still in use in most ISPs, and it's called ISIS. It's not as well known as OSPF, which kind of was derived from it, but it's still in use. And a lot of the ideas also wound up in OSPF. Also, what's kind of ironic is that Ethernet has nothing to do today with what was originally invented. So it was invented as a single link that people, when anyone talked, everyone else could hear what was said. But that was, you still needed a layer 3 protocol in order to carry packets between Ethernets, but the industry just got confused and left that out. So I was responsible for designing something that allowed you to hook many Ethernets together in a way that didn't depend on the computers attached to it to have implemented the layer 3 protocol. And that is known as spanning tree, the spanning tree algorithm. And so that I thought was only going to last for a year or two until people put layer 3 back, but it was so easy to use and so self-configuring compared with IP, which was the layer 3 protocol that people chose, that sort of to my horror they were still using it. And it's not an optimal way of hooking things together. It was just the best that could be designed given the constraints that we had to work without changing the Ethernet packet in any way or changing how the computers worked with it. So that is suboptimal. You don't get best paths and things like that. So about 6 or 7 years ago, I designed another thing that is that allows you to gradually migrate from spanning tree to something that allows optimal paths, multipathing, anything that a layer 3 protocol would do, without having to change the nodes, or to have to throw away all of your spanning tree bridges. And that new thing is known as TRILL, TRILL, which stands for Transparent Interconnection of Lots of Links. I think I know what you're asking me. Yes, so part of the spanning tree algorithm, because I had an entire week to work on it, of which I spent one night realizing exactly how to do it, 2 days writing the spec, which was sufficiently complete that people implemented it without asking a single question, and the remainder of the week I wound up writing a poem that is the abstract of the paper. So the title of the poem is Algorhyme, because every algorithm should have an algorhyme, and the poem is, I think that we shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First, the root must be selected. By ID, it is elected. Least cost paths from root are traced. In the tree, these paths are placed. A mesh is made by folks like me, then bridges find a spanning tree. I happen to also write a book on layers 2 and 3, which it was such a fuzzy field full of marketing hype and so confusing. I believe that the book was a significant contribution in terms of organizing people's thoughts. And then I did a second book with co-authors on cryptography and network security. So, and that book is called Network Security, Private Communication in a Public World. The first book is called Interconnections, Bridges, Routers, Switches, and Internetworking Protocols. I seem to like to put everything into the title. But yeah, I've also done some interesting stuff in security in terms of authentication, authorization, the ability to create data with an expiration date, so that even if the backups still exist, because once you make a lot of backups, you'll never be able to guarantee you get rid of all of them. But once a file expires, once you've given an expiration date, the day after that, it's impossible to recover. And this is, like everything I've done, is very simple, very practical, easy to manage, zero performance overhead over a traditional encrypted file system. Yes, part of it is because I really dislike technology. I am not a gadget person. I literally went to college without knowing how to change a light bulb. It was something I would just tell my father, and a few days later it was fixed, and I never even wondered what he did. I assumed it was dangerous or difficult or somehow. But I think we need more people in the field that dislike technology, that can design things, that work as transparently as possible, so that people should not need to have to understand what's going on inside in order to use it. In the beginning, it was like, well, isn't email amazing? And you can send email between things, and you can do file transfer. That was sort of, I don't think people imagined much beyond that. But so there's the good things that work that I absolutely am astonished that they work. They shouldn't be able to work. So for one thing, the idea that you can search for something on the internet and you get back an answer instantly, way faster than if you're searching through your email for a particular email thing on your one machine. How could that possibly work? I even sort of know how it works, but I still don't actually believe it. Another thing that's amazing is that you can search for something like shoes, and you can find some merchant that you never heard of before in some country that you never heard of before, send them, your credit card, and the shoes appear, and your credit card isn't stolen as a result. Yeah, it's just astonishing. Another is like when you search the whole PageRank business. It would just be so easy for people to post bad information, and some really scary things like wrong information about things to do if your child ingests some poison or something. And yet, even though I'm sure there's things like that, because of the PageRank stuff, you see the correct information first. Oh, another thing is Wikipedia. That, by any logic, it should just be filled with just graffiti scrawlings of ranting, people. But it's one of the best sources of information you can get. Right, that's an amazing thing too. But on the other hand, there were negative things that nobody foresaw. So one is spam. We're just getting flooded in spam, and most of it is caught by spam filters, and yet you still see all of this. And what's really kind of tragic is that there's a lot of people that, despite being that many years with these scams about, oh, I have $20 billion I need to get out of this country, and your email address seemed like a reputable person, so you can have 10% of it. And people, quite tragically get caught up in that. So it only takes a very, very tiny percentage of people to get fooled by that to make it worthwhile for these, horrible criminals to do it, because it costs them almost nothing. And another thing that nobody saw coming is distributed denial of service. So they were thinking, well, one bad guy, how many messages could they possibly send? But this notion of being able to break into tens of thousands of nodes, in the early security papers, people said, oh, you don't have to worry about denial of service because it wouldn't benefit anybody. But there's entire black market kind of economies in terms of I have 10,000 bots, 10,000 machines I've compromised, and if you want to attack somebody by sending them lots of traffic, this is how much I will rent my army for, per hour or whatever. I've always wondered a little bit about exactly how you pay these criminals when you rent their bot army, but because you're a criminal, they're a criminal, what kind of currency do you actually use? But all of these things are just astonishing to me. I was always good at science and math. I loved logic problems, and if people had asked me what I wanted to do when I grew up, if I had known, at the time I would have said, gee, I'm interested in pretty much anything. I just want a job with people that I enjoy working with, that is something I'm reasonably good at and that pays me enough to live on, and I do not have expensive tastes. If I'd known a little bit more about computers when I was younger, I would have modified that statement by saying, oh, I'd be happy at pretty much anything as long as it didn't involve computers. But but I'm very, very happy in what I do. So the thing is that there's this traditional stereotype of an engineer, someone that built a ham radio when they were 7 or built a computer out of spare parts or whatever. And people, there's two forces. One, there are people that believe they wouldn't be good in this field because they weren't like that, and hiring people who think that, oh, you're not in the true spirit of engineer if you don't do that. But the thing is, you need people that think at different levels. So although I'm not a dive right in and start writing code kind of person, I'm actually someone who thinks about a problem from different angles first and gets to the very simple, obvious solution, finds the right problem to solve and exactly how to do it. And I can dive into with an implementer and discuss what the data structures should be and what the algorithms should be. But it's sort of this thoughtful conceptualizing first, rather than the great enthusiasm, just understanding a few special cases and writing code for those and hearing about other things. So that's what we really need. We need to have a mixture of people, those that have actually met actual human beings and know what they would be likely to do, rather than people that have pop-up boxes about, do you want to display only the secure items, which I happen to know even what that means, and it still doesn't mean anything. You need the people that can think about a problem thoughtfully and conceptually first before worrying about the actual details. Someone, again, that can examine two things without worrying about the actual details of syntax and try to get to the heart of what the pros and cons are, as well as the people who just incredibly enthusiastically like to write code. So we have to make sure that the young people understand that it's a very wide field, and that being different from everybody else in the field is likely to mean you will find an ecological niche in which you'll be very valuable, as well as making sure that people who are creating a team understand that it's very important to mix people with different skills. One thing that's incredibly exciting about the web is that we can really democratize education. Instead of just being something that's only available to people who can drop everything else in their life and live someplace on campus and spend, who knows what it is these days, $6 million or whatever per year for tuition. It's been a long time since I was in school, so I don't know what tuition is right now. Instead, there really ought to be a lot of well-organized resources so that you can learn things yourself. Now, one of the problems is that there's likely to be a lot of real junk out there too that would waste your time. So if there would be some way of making sure that you can find the right kind of courses and teach yourself, and you may not be able to get accredited, maybe you could spend extra money to be officially accredited after you've done that. But even in the traditional, only certain people get accepted into the particular university to take these for credit courses, there's still a lot of ways in which the web can make it easier for those, by videoing the lectures so you can review things that you haven't seen, by having an online community where people can ask each other questions and tutor each other and so forth. People say, isn't it great? The internet is so powerful that you can't prevent knowledge from getting out. It's actually kind of the opposite. In the old days, when the only way that you could get news, for instance, was on the three major networks, the information had to be fairly reasonably balanced, or else they would lose their license. These days, no matter what bizarre belief that you have, you can manage to focus in on, there's so many TV channels. You can find a TV channel that only reinforces and magnifies what you believe, and it's motivating. They are motivated to do that because that's what their listeners really want to hear. They don't want to hear anything on the opposite side. And websites also, if you believe that earthworms are telepathically controlling our thoughts or something, you can find 50 people across the earth that all believe the same thing, and in the same community it will seem like it must be true. So it is very difficult to separate good information from bad. And interesting, my thesis was on how to make a network work, even though some of the switches are malicious. And so a distributed algorithm is one where everybody's doing their own piece of the puzzle and it all forms this magnificent symphony. But imagine if some of them could give wrong information, or even if they're doing the protocol correctly, forwarding packets incorrectly, or flooding the network with garbage, or working perfectly for everybody except throwing away your packets. How could you make a network work? So when I proposed that as a thesis topic, everyone said, oh yeah, that's like really hard. But I've never done anything hard. So once I thought about it and I said, oh my gosh, it's simple and even reasonably practical, then I was nervous I wouldn't get a PhD for it. So I asked somebody, is there any minimum length to a thesis? And the professor I asked said, well, it either has to be long or good. But that's another interest of mine, which is people just kind of assume that all information is correct. So there's this web of trust with certificates, for instance, where anybody can sign anybody else's certificates, and you have this public depository where you start with someone that you know, the key of somebody that you know, and then you just search through the database to find a path to the name that you want. Well, this works fine in a small community where everybody is only putting in trusted information, but it only takes, one guy to start putting in false identities and false certificates before the whole model falls down. Another thing is somebody was doing some research on trying to make inferences from information on the web. So, just looking at stuff that happens to be on the web, and the example was Flipper is a dolphin and a dolphin is a mammal, so therefore you know that Flipper is a mammal. And I said, well, that's great if everything on the web is true, but if you actually turned it loose on the web, you would conclude that the cause of global warming is women working outside the home or something like that. It's hard to imagine that this whole wonderful thing won't fall apart. Just we're already drowning in spam and denial of service and malware where you get infected. In the old days, it was just don't be stupid enough to put in a possibly infected floppy into your machine to boot it. But now it's a matter of don't open any email message, don't attach to any website, don't even turn your machine on, in which case you know that it won't get infected. But that's not really acceptable. So, I'm hoping, of course, it sort of has to. Society is so dependent on it today that these things have to be solved. I'm nervous about running out of wireless bandwidth with everybody just saying, well, we should be able to watch 7 HD movies simultaneously, one on our elbow, one on our wrist. Just being so casual about assuming that everything will be connected at all times with high bandwidth just seems like that's going to fall apart. So I think people need to rethink that. They also want everything to just seamlessly talk to each other. And you also have to be careful with that because you don't want your neighbor controlling your thermostat either accidentally or maliciously. So one of the things that I think could possibly help is if people didn't make their software implementations so extensible. If really all you want to do is read email and look at websites, is it possible to do it in a way that you're not required to download code in order to view the website? It seems like that ought to be possible. And so to have a machine that there's no way to download code on it, but just doing the very simple things, if most people using the web, that's all they really need to do, you'll have a much more resilient ecosystem. My co-author on the security book once gave a talk saying, many years ago, probably, 20 years ago, saying, is it too much to ask for that the web be as secure as a telephone? With a telephone, you dial a number, you know who you're reaching. You can dial any number without it destroying your phone. And then he gave the same talk many years later, and he said, well, the good news is, yes, the security of the web is approaching the security of the phone, but the bad news is it's because phones are also getting to be general purpose machines that you download software, and they're just as easily infected as regular machines.